Hello, everyone. Welcome to the final notes on the properties. We have 3 more lessons to go, but the property videos are done after this one. So we did 2 multiplication properties, and we are going to do the last one here, which is a division property. So jump right in, simplify a to the 5th over a to the 2nd. So what is this saying? So again, I've done this in pretty much every video so far. I'm going to lay it out in a way that is not quick, but hopefully illustrates what's happening better. So a to the 5th on top is 5 a's on top. A to the 2nd on the bottom is 2 a's on the bottom. Now, the fraction bar means division. So a divided by a cancels it out, right? Makes 1. Well, another a cancels out. And what does that reduce to? What's left on top? A to the 3rd. There's 3 a's on top, so it's a to the 3rd. Okay. So it says try this one. So h to the negative 3rd over h to the 2nd, or h to the 12th. Okay, so this one, a lot of people mess up on because we back up a second. People realize, oh, I can just subtract 5 and 2 and get 3. That is the shortcut. You can do that. However, with the negatives, it can cause some mistakes, which, yeah, I'll show you what a lot of people get here is h to the 9th or h to the negative 9th or something like that. Well, if I make everything happy here, so I'm going to go over here and make everything happy. So h to the negative 3rd is not happy on top. It wants to go to the bottom. H to the 12th is already on the bottom. There's nothing left on top. So we put a 1 there, right? So then we got h to the 3rd, h to the 12th on the bottom. Well, those are on the same side of the fraction bar. Well, if they're on the same side of the fraction bar, that would be h to the 15th. I add the 3 and the 12 and get 15. So the answer to this one is actually 1 over h to the 15th, okay, which you may not have gotten by subtracting. So why did I show you both of those? I just told you, many people will mess up with the subtraction, especially with the negatives. So I've come up with a process that can get rid of that problem. Now, this is my process. I will tell you, if you look at a textbook or you look on Khan Academy or somewhere like that, you will see them tell you to subtract the exponents. And you can, like I said, you can, but you will, it's very possible you'll mess up, especially when there's negatives. So I'm hopefully going to get rid of those negatives. I kind of showed you with that previous problem what to do. You want to ask and answer these 3 questions, and they'll go quick. They're not hard questions. Is everybody happy? Basically, are there any negative exponents? Okay. If there are, you make all the negative exponents positive by moving them. We talked about that for a while. Once you've everything moved, you ask, where are there more of the bases? So whatever the base is, where are there more of them? And then once you have figured that out, top or bottom, you say how many more. So that's where you would subtract. How many more? The answer to this question is the exponent. And if you do these first 2 things and then ask this 3rd question, you will find that the answer is never negative. So you don't have to deal with negative exponents other than in step 1. Okay, so I'm going to go through that process here with these practice problems. So 4 here on the front. So c to the 9th over c to the 15th. First of all, is everybody happy? Yes, there's no negative exponents. Where are there more c's? There's more on the bottom. So here's what I'm going to do. I'm going to make my fraction bar. When I answer question 2, where are there more c's? You put the c wherever there are more. So there's more on the bottom, we're going to put the c on the bottom. Well, how many more are there on the bottom? Well, 15 minus 9, there's 6 more on the bottom. That's my exponent. Now I just finish it up by putting a 1 on top, and I'm done. Okay. Number 2, is everybody happy? No, I got to make things happy first. So I'm going to put p to the negative 3rd, that's not happy on top, put it on the bottom. P to the negative 8th, not happy on the bottom, I'm going to put it on the top. Now I'm going to use this and ask those same 2 questions. So I've already made everything happy. Question 2, where are there more p's? Well, there's more p's on the top, right? How many more on the top? 5. I don't need to put it over 1. You can, but the answer to this one is just p to the 5th. All right, number 3. Is everybody happy? No. M goes to the bottom, becomes m to the 3rd. M to the 6th is already happy on the bottom, so it stays on the bottom. Where are there more m's? Well, there's definitely more m's on the bottom. They're all on the bottom. How many are on the bottom? 3 and 6. There's 9 on the bottom. Just put a 1 on top. So 1 over m to the 9th. Number 4. Okay, so we've got 2 different bases here. The first 3 questions, we only had 1 base on each of those. Now we have 2. Basically, you're going to go through question 2 and question 3 twice. Or if there was 3 bases, 3 times. So on. Notice the first question I skipped because I already see that all the exponents are positive. So if they were negative, I would move those first and then go through the second and third question. They're already all positive, so I'm going to go ahead and go through the questions. Where are there more C's? On top, right? How many more? Well, there's 7 on top and there's 1 on the bottom. Can't forget that 1 there. So there's 6 more on top. Where are there more D's? On the bottom. So I'm going to put a D on the bottom. How many more? There's 5 more on the bottom. And that's your answer. Okay, so those were pretty basic ones. Now we're going to go into the backside and move on to some tougher ones. You can see that they're a little bit tougher here. Okay. What do you do when you have a fraction raised to a power? Okay, so right away I'm jumping into that. The exponent gets put with everything in the top and the bottom. So it's a lot like what we did in the last lesson. Okay, so 2/3 to the 3rd power. Each base, and 2 and 3 are both a base, has an exponent of 1. And so what I'm going to do first is I'm going to multiply each exponent by 3. And then simplify. 2 to the 3rd power is 8. 3 to the 3rd power is 27. All right. Number 2, 4 has an exponent of 1. X already has its exponent there. So now I'm just going to multiply each exponent by 2. So 1 times 2 is 2. 3 times 2 is 6. And just simplify everything from there. 4 squared is 16. X to the 6th is just x to the 6th. Okay. Make sure everything has an exponent. Number 3, x to the 3rd, already there. Y has an exponent of 1. And z already has its exponent. I'm going to multiply each exponent by 4. So x to the 12th, y to the 4th, z to the -8th. Now, can't have negative exponents. So x stays on top, y stays on top, z is not happy on the bottom, it goes to the top, becomes z to the 8th. Okay, no fraction in this one. If you wanted to put over 1, you could, but there's your answer. Number 4, make sure every base has an exponent. 3 does not have an exponent. I'm going to put a 1 there. M already does, N already does. 2 has an exponent of 1. P already does. All right, so now I'm going to multiply each each exponent by 2. So 3 to the 2nd, M to the 6th, N to the -8th. 2 to the 2nd, and P to the 12th. Okay, now I have a couple things I need to do. I need to simplify both the numbers. Okay, and then I also have to move N. So I'm going to go ahead and just mark that there. 3 squared is 9. M to the 6th stays on top. 2 to the, N goes to the bottom. I know that. N goes to the bottom, becomes N to the 8th. But I'm going to go ahead and do 2 squared and say 4. And then P to the 12th stays on the bottom. Okay, that's done. But one thing you do want to check, since I made numbers here and here, a lot of times those can reduce, but 9 and 4 don't, so I am done. But make sure you check that. Okay, number 5, got a negative exponent. Doesn't really change much. Make sure each exponent has, or each base has an exponent. So 3 to the 1st, 4 to the 1st. And now I'm going to multiply 1 times -2, which is -2, and 1 times -2, which is -2. Now, what I will see a lot of people do here is they will do -9 over -16. Don't do that. Negative exponents, again, you should know this by now, means move the base. So 3 is not happy on top, it goes to the bottom and becomes 3 squared. 4 is not happy on the bottom, goes to the top, becomes 4 squared. Now I simplify. 4 squared is 16, 3 squared is 9. There's your answer. Number 6. Each base has an exponent of 1, and I'm multiplying each of those by -1. So 2 to the negative first, r to the negative first, s to the negative first. What happens is 2 goes to the bottom and becomes 2 to the first, or just 2. R goes to the bottom and becomes just R. S goes to the top and becomes just S. You could put 1s on all those, but you don't need to. Okay. What I want you to see, why I did this one, look at the original problem and look what happened to the answer. It basically just flipped the fraction. And look over here. A negative exponent will flip the fraction. It doesn't make it negative, it flips it. Okay. Got 3 more. Scroll down here. 3 more. And then scientific notation to follow it up. All right. Looks a lot more difficult. Got a lot of stuff going on here, but it's not, as long as you just follow the same process. Multiply each exponent by -3. Every base does have an exponent already, so I don't have to put a 1 there. -5 times -3, 15. 2 times -3 is -6. And -4 times -3 is +12. Now I just got to move things around. X stays on top. Y goes to the bottom, 1 to the 6th, and Z stays on the bottom. Done. All right, number 8. 4 needs an exponent. 2 needs an exponent. A needs an exponent. Okay, so here we go. 1 gets multiplied by 2, 5 gets multiplied by 2, and -3 gets multiplied by 2. On the bottom, 1 gets multiplied by 2, 1 gets multiplied by 2, and 7 gets multiplied by 2. Now, there's a lot going on here. I'm going to take us, I'm actually going to go down here and give myself more space. 4 squared is 16. A to the 10th. B goes to the bottom, right? I'm going to go ahead and say 2 squared is 4. B goes to the bottom and becomes B to the 6th. A to the 2nd stays on the bottom, and B to the 14th stays on the bottom. Now, you see how you have 1, 2 A's, and you have 1, 2 B's. If you have 2 of the same base in your problem, you're not done. You have every property you need at this point to combine those and make it 1 of the same base. So I'm going to go ahead and do that. 16. Where are there more A's? There's more on top, right? So I'm going to put the A on top. How many more are there on top? 8. Okay, that's what we did on the front side. Where are there more B's? On the bottom. How many more? Well, they're all on the bottom. So what do I do with the exponents there? It goes back to lesson 3. 6 and 14 makes 20. A lot of people think they're done here. But if you go back to number 4 on this page, I told you, you need to make sure you look at these and see if they can reduce. And they can. 16 and 4, it's basically a fraction. 16 over 4 reduces to 4 over 1, or just 4. So my final answer here is actually 4a to the 8th over b to the 20th. You could put a 1 in front if you wanted. You don't have to, though. Okay, so that right there simplifies to that right there. Kind of crazy, but it follows all the rules, and there you go. All right, last one, and then we're going to go to scientific notation. The top is already simplified. I can't do anything to that. There's no exponent on the outside, so I'm going to leave that 9k to the 3rd, p to the 2nd. The bottom, I do need to multiply each exponent by 3. So 3 has an exponent of 1, k has an exponent of 1. So it's going to be 3 to the 3rd, k to the 3rd, and p to the 9th. Okay. Before I do anything, I'm going to go ahead and multiply 3 to the 3rd and get 27. All right, we'll go ahead and focus on that because I just talked about it. Those can reduce, right? 9 and 27, I can take 9 out of both of them. That's a 1 on top and a 3 on the bottom. So I'm going to put 3 there. I can put the 1 on top, don't need to though. Where are there more K's? Well, they're equal. What happens there is they completely cancel. There's no K's left in this problem at all. Okay, that makes K to the 0, which is 1, which we don't write. And then where are there more P's? There's more P's on the bottom. How many more? 7. So what's left on top? Just the 1. Okay, and that's the final answer for number 9. All right, scientific notation. Okay, a lot of people get confused with this one. Not sure why. It's very similar to what we did with multiplication. What you do is you divide the A values and then you subtract the exponents. Like with multiplication, we multiplied the A values and then we added the exponents. Now, with subtraction, you always subtract top minus bottom, always. So this is the one time when you might have to deal with some negative numbers, and be careful with that. All right, so with this one, I'm going to do 7.5 divided by 2.5. You do that, you get 3. So 3 times 10, and then you always subtract 4 minus 6. 4 minus 6 is -2, and there's your answer. So that one was pretty easy because the A number was between 1 and 10 right away. What happens if it's not? You know what to do. 4.2 divided by 8. Okay, so 4.2 divided by 8 is 0.525. Okay, not going to do anything with that yet. I know I have to, but I'm not going to do it yet. And then I'm going to subtract. Okay, -7 minus 3. Make sure you understand how to do that. A lot of people go very quickly on that and say 4 or -4. It's not either one of those. -7 minus 3 is actually -10. Okay. Now we've done this a bunch. We know we need to put the decimal there. So it's 5.25 times 10. We made that number bigger, right? 0.5 we made bigger to 5.25. So we have to make the exponent smaller by 1. So -10 minus 1 is -11. And there's scientific notation. Okay. We've done everything with scientific notation now and everything with the properties. Now we should be able to simplify all of these exponent expressions. Okay. And that's it.